Okay, so for this last part of the problem, we're going to solve the initial value problem with two initial conditions given. And you notice that they're always going to be given to us in the form of the first derivative at a point and then the original value of the function at that same point. We can't use different points because those are called boundary value problems, and it's another topic. So what we want to do first to find our solution is build the general solution, and that's going to require us to use two arbitrary constants, C1 and C2. So our y of t is going to be an arbitrary constant C1 times e to the 4t plus a second arbitrary constant C2 t e to the 4t. We now want to impose our initial conditions. So the first one is y of 0 is equal to 2. So that says that we're going to have a C1 times e to the 0t plus a C2 times 0 times e to the 0t is equal to a 2. So, of course, the second term just cancels out because it's 0. E to the 0t is just 1. So that tells us that the C1 is equal to a 2. The next thing we're going to do is impose the second initial condition, but that requires us to use a derivative because we have our y prime of 0 equals negative 1. So we first need to get y prime calculated, and y prime of t, we saw this before. That was going to have two terms this time, though. It's going to be 4 c1 e to the 4t, and now by product rule, derivative of the first is c2 e to the 4t plus the second c2t e to the 4t's derivative, which is e to the 4 times t. So that's our derivative there, and now once again we need to evaluate it at 0. So y prime of 0 is equal to 4 times c1 times e to the 0 times 4, not 0t. All right, so again, that is e to the 4 times 0 plus c2 e to the 4 times 0 plus c2 times 0 times 4 times e to the 0. All right, and then in here, you will notice that that last term is going to cancel out again. And again, this is equal to a negative 1 that was given to us. So we now have the equation 4c1 plus c2 is equal to negative 1. And c2 then is equal to negative 1 minus 4c1. We can borrow the result of c1 from earlier. So that's negative 1 minus 4 times a 2. So that's going to give us a negative 9. So our solution to the initial value problem is y of t is equal to 2 times e to the 4t minus 9 times t e to the 4t, which could also be written as 2 minus 9t times e to the 4t. And again, you can verify that this is the solution to the initial value problem by going in and first checking initial conditions. And I always find it helpful to check the initial conditions first because that's always going to give you the quickest way to spot an error. So if you plug in 0 for this, you will just get 2, which makes sense up here. The derivative, you could find it and plug in 0. And when you do plug 0 into the derivative, you should get a negative 1 for an answer. And then finally, this solution as well will make the original differential equation true as well. So you can check the two different values of y and the differential equation on the solution that you find.